Hey, hello and welcome everyone. In this video, I'm going to talk about network effects and platform markets, which actually involve network effects as well. So I'll consider two related types of markets, network markets and then platform markets. The basic idea is that, well, the network markets is going to have a sort of a single network externality on one side of the market, so to speak, and the platform market is going to have this network externality exerted on both sides. All right, so what is this network externality? Well, it's sort of our recognition that the number of buyers of a product might be relevant to each individual's willingness to pay. Might be positive, might be negative. But the idea is that other customers' usage choices are relevant for a single customer's willingness to pay of that product. You could think of a situation where, think of like an iPhone or think of like a smartphone. Well, if you're the only one in the world that's got a smartphone, it's got some value to you, obviously. But if a lot of other people have smartphones, now the value of having one increases because of, well, the ability to share information, the ability to interact with a world that's now set up for the expectation that people are carrying these convenient devices around. Obviously, like the applications that operate on the smartphone itself have network effects, such as like if I'm the only person in the world that uses a messaging application and I use that messaging application to send myself files or notes across different devices, okay, good. But the value increases if there's a lot of other consumers who are also using that product, because now you can communicate with them. And so the value of using a messaging application, or think about the value of email. If you email your papers to yourself, I used to have problems with computers crashing or not saving my work or something, and so I got in the habit of emailing myself drafts of the term papers I'd been writing. So I'd have some value to having an email address, even if there's no one else in the world I could communicate with. But when everybody else is using email, you communicate with professors or other, sign up for email alerts or for online retailing and so on and so forth. The value of having email increases in the number of other users of email. Even though having an email address or having a smartphone has some value in itself, there's definitely this network effect. Now, those are examples of positive network externalities. There can also be negative network externalities. So think about like the case where, maybe you don't want to go to school wearing the exact same shirt as somebody else. Or, I've heard historically in the case of dresses or like prom dresses, it's evidently bad if two people turn up to the same prom wearing the same dress, right? This has this really interesting backstory in terms of how that market functions, and you'll have this distribution structure from large retailers such that only so many instantiations of the particular clothing item is going to reach a particular market, so as to avoid, or to be really careful to avoid that situation. And then what do you have? Well, you have the situation where somebody goes to a larger city or online shopping and so on and so forth, and then the whole process is confounded. But that's definitely a situation where there's a negative network externality. There's other negative network externalities. I mean, do you think of other type of like snob effects where you'd want to have some type of exclusive item? Like one of the reasons why I would imagine individuals like having fancy sort of expensive sport cars is because not many people have those vehicles. And so it's a fellow that lives down the road from me and drives this nice sports car. Okay, good. My guess is that their enjoyment of that sports car would not be nearly as high if somebody like me was driving it right by them as well, right? Probably the reason why they wanted it is because there's some level of exclusivity. And so that's important. So the idea is like with network externalities, you've got this positive or this negative influence that the number of other buyers, maybe even the types of other buyers, exert on your own valuation. Now with platform markets, the idea is like you've got multiple groups of consumers. So you could think of like two different types of users of a platform. So on an auction website, you'd have those listing the items for sale, and then you'd have those coming in to buy. So you'd have buyers and sellers. Or with Facebook, you'd have those with a standard account that are posting content for their friends. And so those are ordinary users, and they're definitely exerting some type of externality on each other, depending on what they're posting. And then you've got advertisers, which is a different type of user, right? And so then they're exerting some type of externality on other advertisers. And definitely there's this cross-platform externality from advertisers on ordinary users and ordinary users on advertisers. That's the idea with platform markets. Okay, so that's sort of the conceptual overview, kind of orienting, giving us a perspective on what we're going to do here. All right, the next thing we want to think about is actually going explicitly into network markets. So what I'm going to do is I'm going to talk about network markets in the context of our standard demand curve. Then, right after networks, but before switching costs, I'd like you to think of this lecture. So this is Economics of Entrepreneurship, Network Effects Part 2, which actually typically, so if I was doing this in a standard class, I'd teach this portion, then I'd go to this portion, and then I'd switch into, I move to switching costs, I pick up these slides at switching costs. And so that's how you should think of this. I'm going to actually not do that. Video will be just way too long. I'm going to make 2 separate videos. But you want to think of this one, Network Effects Part 2, coming kind of right after networks. All right, so many markets, kind of talked about a number of them, have a situation where the value of a product to a customer depends on how many other customers purchase or use it. So you think of a situation with, like, I don't know, smartphones or email. We've given those examples as well. Other types of software, obviously social networking sites. Multiplying online games, pretty boring if you're the only person in the game. And the example of the exclusive car, right? And so some of these have a positive effect that more users are exerting on other people. Some of them, like the exclusive car, have a negative effect that more users exert on other people. And the question is, how do these linkages across customers affect the demand structure? Like, quite literally, like, how do we quantitatively model the situation where there's this network effect? So that's what we'll do next. And then there's this further reflection, which is, what does this mean for our firm's strategy, especially if you need to develop a network? All right, so first let's consider the situation with a positive network effect. So here, each consumer's quantity is going to depend positively on the expected quantity of others. Now, this is actually going to lead to something that's going to look kind of complicated in a second. It's actually going to be easy because we're going to make the assumption that beliefs are correct in expectation. So we'll be able to replace expected Q with ordinary Q. So that'll come in a second. All right, so the issue is, when we have a positive network effect, when the firm lowers the price, there's the standard increase in demand, right? Downward sloping demand curves, lower price, higher quantity demanded, but there's an additional effect. There's this boost due to the positive network effect. There's this sort of increasing influence where, as the quantity rises, it's going to take off at this increasing rate because you've got this positive network externality where people's valuations are rapidly rising when more people enter the market. What about raising the price? Oh, that's detrimental, right? Because when you raise the price, you have the standard law of demand story where higher prices, lower quantity demanded. But it's even worse when there's a network effect, especially if some really important, critical, pivotal users leave the network and then take a lot of other users with them. So the idea is, like, if you have this positive network effect, there's this sort of enhanced influence to lowering prices, and there's this enhanced penalty to raising prices. Overall, we're assuming demand is more elastic than it would be without the network effects. We can actually show this. Ultimately, we'll get to the conclusion where you should price lower than without the network effects, other things equal. And that's because you've got this increased benefit from pricing low, in that you'll, on average, have more consumers joining the market, which is going to raise everybody's willingness to pay, increase the valuation, increase the size of the market. All right, so with a negative network effect, we'll talk about this conceptually first, then I'll go to the quantitative development. So here you have a situation where everyone's quantity depends negatively on the expected quantity of others. This is like a snob effect. You've got this desire for being exclusive. So here, the effects of lowering the price, which typically would lead, higher quantity demanded, is going to go the other direction because the good is going to lose its exclusiveness. So as more people are purchasing it, then the reason why a lot of people might buy the good in the first place completely gets undermined. And then in terms of raising the price, it goes in the opposite direction. As you raise the price, you get a smaller quantity demanded, but that actually makes your buyers who are seeking that good for the snob effect or the exclusivity more interested in buying a larger quantity. So what's happening here is demand is becoming less elastic than without the network effect. So other things equal, you price higher than without the network effect. And the reason why is, well, if you've got the snob effect, you want the price to help sort customers such that the ones who are willing to pay for this exclusive product are doing so. All right, so here's the numeric example. Suppose we have a standard demand curve, no network effect. So this is just a standard demand curve, right? Quantity in terms of price, 15 minus 3p. The slope of the demand curve is minus 3. Now, as I'm saying that, remember, we don't typically, this is indeed a slope, right? 3, this is a slope of the demand curve. This is dq dp. We don't typically draw the graph of demand curves. We draw the graph of inverse demand. We'd solve this for price, right? We put our independent variable on the horizontal axis is typically typically our x. The dependent variable on the vertical axis typically our y. Well, with demand and with economics, we have actually quantity on the horizontal, we have price on the vertical. And so, yeah, this is our demand curve, but the one that we'd actually graph, our inverse demand curve, is going to be solved price in terms of quantity. Now, you can do that real quick. We'd move 3p to the other side, move q to the other side. So p is equal to 5 minus 1/3 q is the inverse demand. So the slope of the demand curve is going to be minus 3 because that's the derivative of this thing with respect to price. The slope of the inverse demand curve that you'd probably draw if you're drawing the standard supply and demand diagram would have a slope of minus 1/3. All right, now let's add in our positive network effect. So what I'm going to do is I'm going to say, all right, well, here was our standard demand curve. That's this part. Now here's my network effect, 1/2 times the expected quantity. All right, so this expected quantity, this is just our belief about how many people are going to be in the network. This 1/2, this is like some weighting for like how much that matters. Suppose this is a 0, then there's no network effect, right? Suppose this is huge, then the network effect is really valuable, right? So that's what this is doing. This is weighting. This 1/2 is basically weighting how much the expected network size is going to matter. All right, so the expected Q is the total quantity the consumers expect to be sold. It's like our conditional demand curve. Demand conditional on expectations about what consumers are going to do. And as I said, this 1/2 times the expected Q, that's our network effect. The demand for the product by consumers depending positively on the total quantity they expect to be sold, right? If this is negative 1/2, then it would be depending negatively on the total quantity we expect to be sold. If for a 0, it's not depending on that at all. All right, so the next thing we want to do is we want to say, all right, to simplify this down, because this looks super complicated, especially because I've got a word in an equation, it's going to go away really quick because we're going to believe that we're going to assume that expectations are correct in equilibrium. So the expected Q is equal to ordinary Q. Now we've got something that we can collect like terms and make a demand curve. So to get the slope of our overall network effect inclusive demand curve, we're just going to collect our like terms and move this to the other side, right? And this simplifies down to Q is equal to 30 minus 6p. And you can think the slope of this thing. So the slope of this demand curve is minus 6, right? The slope of the thing we'd actually graph, we'd solve this for price in terms of quantity. So that would be price is equal to 5 minus 1/6 Q would be our inverse demand. If you draw price on the vertical, quantity on the horizontal. Anyway, in this example, the slope of the overall demand curve, minus 6, is more negative than the slope of the demand curve without the network effect. It's more elastic, right? The slope of the demand curve with the slope of the overall demand curve, inclusive of the network effect, is more elastic. And it's got a bigger slope. Without the negative network effect, with the negative network effect, you get the reverse effect. So adding the negative network effect would make the slope less negative or less elastic. Right? But getting back to this example, because sometimes it's weird to kind of see this written out like here. So what do we mean that this is going to be more elastic with the network effect? Well, let's just think in terms of how we would draw the graph. So here is our original demand curve. Quantity is equal to 15 minus 3p. Our inverse demand, the one that we draw, would have a vertical intercept of 5, and the slope of the demand curve, or the inverse demand curve, would be 1/3 with no network effect. And then with the network effect, the overall demand is this. The inverse demand would be price is equal to 5 minus 1/6 Q. With the network effect, this is going to be flatter, right? With the network effect, 1/6 is a flatter slope than 1/3, and flatter inverse demand curves correspond to more elastic demand. Think about like the horizontal demand curve for an individual competitive firm. It's perfectly elastic. adding this network effect, adding this positive network effect has made the demand curve more elastic. And if this is a negative network effect, it'd go the opposite direction. Adding the negative network effect would make the demand curve less negative or less elastic. There, again, we're talking about the demand curve written quantity in terms of price. If we're talking about how we'd actually visualize the graph, like from principles of economics, thinking about inverse demand, it'd look like this. Reason why is we want to be comfortable with both. We want to be comfortable. This is the same relationship. This is just quantity in terms of price, price in terms of quantity. Both of these carry the exact same information, as do these two. All right, so at this point, if I was typically teaching this, I'd switch over to this set of lecture slides and then talk about the quadratic network demand. And I'll put that link in the description. However, I want to kind of continue on with this lecture because otherwise it's weird just kind of breaking it up. It'll just be too long. And so, all right, next thing I want to think about is the role of switching costs in network markets. So the example we've seen so far, it's pretty simple examples, and in general in the class I want to consider kind of the simplest model that'll capture the intuition that we need. Even so, we want to realize that there's other sort of implications, especially when there's a time dimension. Often network products are longer lasting, or could be significant switching costs that are relevant down the road in the future, such as once you've adopted a particular technology and you've got a lot of other users on the same network, it can be really costly to switch to another one. This is actually one of the reasons that's sort of reinforced the dominance of Microsoft and in the PC market, is that you've got a lot of people who have on the particular software network and gotten used to the software and are sharing files and kind of have a long history of the particular product. It'd be really difficult for another operating system to capture much of the market. Although, Apple's been trying since, they kind of both rose up more or less together from early 80s. And interesting story between them. All right, so anyway, when this is the case, when we've got these significant switching costs, we've got this issue where the installed base, the number of people that have previously adopted, is really important. So you could think of, well, the historical example, thinking about fax machines, thinking about MySpace versus Facebook, thinking about DVD versus Blu-ray, both of which are more or less rendered obsolete by streaming services. Instagram versus Flickr users. Think about the size of how the size of the base is relevant. Number who have adopted in the past is relevant for the growth of the future network. One of the things that really benefited Instagram was just convenience relative to Flickr, where maybe Flickr came up a little bit too early, largely based on standard website, whereas Instagram, I think, was more readily integrated into smartphones. And so though I'm sure Flickr's got an app, but probably not as convenient as Instagram and required a switch for existing users. Whereas Instagram, there's a website for Instagram, but it's primarily smartphone based. And transaction costs and convenience is super important. All right, so because of the positive network effect, the installed base from prior year sales has an effect on the current demand. It'll positively affect in the case of a positive externality. In this case, the optimal pricing strategy might be to try to build up your installed base, price low initially, give away free or discounted access to try to get a large number of users. Then, once you've got a critical mass, the goal is to you have the ability to start raising the price and then to be able to extract profits. Assuming that this is going to lead to a situation where demand is already a little bit more inelastic than it would have been initially, and you've got enough consumers in the network that you're able to raise prices. Why? Because the value of the network has grown so much. You're able to, so think about what's happening with the network effect, right? As more users join the network, the willingness to pay for each individual is rising, maybe just by a little bit. But if you think about like starting off on a particular social media site, maybe you're a really early adopter, and then all your other friends join, something like that, or everybody else, people at across the country, whatever it is, across the world. So you've got a lot of other users, and all of a sudden, as more people are joining the site, your valuation is rising all the while. And the company is able at a certain point to start extracting some of this increasing value that they're creating for you by raising price somehow, adding advertisements, and so on and so forth. And so the idea is that consumers have some initial willingness to pay that's relevant for their purchase decision. As more people join, their valuation is rising, more value add is being created. Firm can come back and try to capture some of that additional economic value by raising prices later on. That's the idea. All right, so we can show this in the standpoint of a two-period dynamic model, kind of like what we saw with dynamic pricing before. Basic idea is a simple two-period model. We have our price, well, we have our revenue, our profit from period one, our revenue, our profit from period two. What makes this profit? Well, it's price minus marginal cost times quantity, it's profit. Price minus marginal cost times quantity, it's profit. So what's happening here, P1 is the price in period one. So here's my markup in period one. It's going to negatively affect Q2. So the idea is the higher price initially, the fewer people we're going to have in the subsequent period because we had fewer people adopt, so therefore fewer of their friends adopt, and so on and so forth. So what's happening? Well, the price in period one is negatively affecting our installed base, which we're representing by Q1, which is the number of people who buying in period one are those already with the product when we enter period two. The lower quantity in period one reduces the quantity in period two. Why? Well, if you have fewer users from the previous period, now the network externality is smaller. The value of being on the network is smaller, so you can have fewer people buying in period two. All right, so the idea is a lower P1 is going to lead to a bigger installed base. A higher P1 is going to lead to a smaller installed base. And to the extent that the installed base is necessary or is really important, you want to price low initially. So the observation, if we have positive network effects and we have competing firms, competition can get really fierce as companies are racing to have their product become dominant. So in some sense, the standard where the market is tipping towards the product. Once this happens, it'd be really difficult for potential entrants to compete. So the idea is, like, think of what happened with Facebook overtaking MySpace. Initially, Facebook was entirely free. It's free, and they said it'll always be free, but it's not free because you're paying with your time, and a lot of what you're paying with your time is viewing advertisements that you're scrolling through. The other thing is a lot of the value on Facebook is created by users, and so you're paying for Facebook in some sense with the content that you're donating to the network. And so anyway, the idea is like, well, initially there's going to be fierce competition, and then once we've got a dominant firm, then they start raising prices or increasing advertising and so on and so forth. This happens with like telecom as well, or like cable. When these companies are competing for for consumers initially, there'll be low introductory pricing, and then after you're on the network, then they can raise the prices. Part of that is like a switching cost, but that type of switching cost isn't actually all that different from the switching cost that's inherent with a network externality, because if you're leaving the network, well, you're losing this benefit from the network effect. So what happens? Well, the race to be the dominant product can give us really low prices, really big promotional campaigns, large investments in product quality. Often initially the firms lose money, and then what ends up happening though? Well, the increasing switching cost for the product helps prevent the market from switching away. And so what happens is you make this large investment, consumers really like the product, the large network externality reinforces the valuation, and then in the future the opportunity cost of the switching cost and then the opportunity cost of being on a different network gets great, so people just stay on the network that you've invested in. Such is the case where, think of like the massive investments in quality for like Amazon with their product reviews and eBay with their reviews, so on and so forth, which raises the costs of individual vendors or sellers leaving because they've established a reputation on one platform. All right. So since I mentioned platforms, next we'll talk about platform market. So here we have externalities between customers, but we have externalities between customers and between customers on different sides of the platform, different sides of the market. So a two-sided market, a platform, has two distinct groups of customers. So we have like buyers and sellers on an auction site, or we have users and advertisers on like Google or Facebook or something like that. Think of like Uber. So you have drivers on one side of the market and then passengers on the other. Or OpenTable, restaurants and diners. eBay, Craigslist, you have buyers and sellers. Facebook, users and advertisers. These are all examples where you've got two sides of the market, and you have a situation where you can think about the externality that is being exerted within each side of the market and then across. All right, so platform markets are similar to markets with positive network externalities, except the externality accrues to the other side of the market. Well, the relevant externality we're going to be thinking about is going to accrue on the other side of the market. So this is the situation where the more users are on a particular site, the greater is the positive network externality on advertisers. So in this situation, what do you want to do? You want to lower prices initially to be able to get a large number of consumers so that you can get advertisers onto the market or onto the site. Now, there's some really complex issues here, because if we have a platform like this, we've got at minimum two prices to set. You have the price on the A side of the market and the price on the B side of the market. Like, how much are you charging ordinary users, and then how much are you charging advertisers? Well, for Facebook, they're charging ordinary users implicitly a price of zero, explicitly a price of zero, but they charge advertisers to advertise on the network. And it's interesting to reflect on which side of the market you're going to be able to extract profits from, typically the more inelastic side. All right, so another example would be like OpenTable charging restaurants to join the service, or they could charge diners to access the service, or they could charge both. And you have to think about which is the optimal one to try to extract profits from. Right? Do you try to extract profits from the A side of the market or from the B side? Well, if the value of the customers on the A side of the market is high to the customers on the B side, maybe you want to charge negative prices to the A side. Or vice versa, if the B side is very high to the markets on the A side, then maybe you want to charge negative prices to the B side of the market, right? So or give away free stuff or access and so on and so forth. So an example would be like dining points on OpenTable to try to recruit diners. Free content in advertising-based media or in information markets. So free content for Google search, free content for terrestrial radio. So listen to radio for free, but then you have to listen to the advertisements. So the idea is like, give people an incentive, a reason to use the product, to be on the network, so there's a large number. And then on the other side, charge the advertisers a lot to reach those customers that you've pulled in. All right, so here's a pricing example, optimal pricing example. So I'll walk through kind of a numeric example. I'm not going to go through all the details, but I'll walk through a lot of the logic for how this would work. So PA is the access price for customers on the A side of the market. PB is the access price for customers on the B side of the market. Our group A demand looks like this. QA is dependent on, well, the price of the A side and the quantity on the B side, right? So there's this capturing this network externality that's affecting from side B, that's affecting side A. And group B's demand, well, it's dependent on their price. It's also dependent on the number of users on the A side of the market, right? There's externalities on each side of the market. So here, the size of the B market is affecting the size of the A market. Size of the A market is affecting the size of the B market. And we've got this nice symmetry between them, right? 10, 1, 1, 1 half, 1 half. All right. So how do we solve for the profit maximizing price? Well, we have to write down profits as a function of the decision variables, in this case, PA and PB, or we could write this out where our firm's choosing QA and QB, and then prices adjust. We're going to assume marginal costs are zero. So maybe all the costs are going to be our setup fixed costs, which are going to be irrelevant to the marginal pricing. Here's going to be our profit function, right? So it's going to be price times quantity in market A, and then price in B times quantity in B, and then less the fixed costs. All right, so we need a little bit of work to be able to derive our demands, right? QA is a function of PA and PB, and QB is a function of PA and PB. So here was our demand equations from before. I haven't done any work yet, right? I just took these same demands that we defined. And now what we need to be able to do is we need to just substitute for QB, right? So if we drop this in, if we drop in 10, so this would be 1 half times the quantity 10 minus PB plus 1 half QA, right? Now we'll have an expression that's got QA in it, it's got a PA and it'll have a PB and a QA, and then we'll solve and get this. And we'll do the same thing on the other demand. Of course, because we have symmetry, it's going to look the same. All right, so it's just substitute one into the other and then solve out for whatever is the respective demand. Now we can write profit just as a function of our decision variables, which are PA and PB. So that's this right here. So here was our demands. Again, I haven't done any work here. This is just this line, right? Just took this line and put this here. Now I replaced for QA and QB the expressions that we found, replaced those into our demand function right here and right here. And now I can take d pi dpa and I can take d pi dpb as my partial derivatives with respect to my two choice variables, right? PA and PB. Set equal to 0 gives us our first order condition, and then solving. If you do this, we'll get prices PA and PB is equal to 5. And so that'll be our optimal prices. My question, are the equal prices surprising? Shouldn't be here. We have this symmetry, right? So we had a tremendous amount of symmetry in this problem, right? So the problem looks the same from the perspective of side A and side B. That's specific to this example, right? All right, so here's another example. So here's my group A demand, and here's my group B demand. So group A demand is going to be 10 minus PA plus 1/2 QB. No, that's what we had from before. Suppose my group B demand, 12.5 minus PB. Oh, well look, here the customers in group B don't care about how many consumers are in group A. So this might be a situation where group B is like our readers. They don't care about advertisers, but our advertisers care about how many readers there are. Okay. All right, so if you do the same thing here, we would get PA is equal to 7, PB is equal to 4.5. And the idea is, well, let's raise prices on the customers that don't generate the positive externality and lower the prices on those that do, right? So this is relative to this situation where we had symmetry. Now suppose it's the type B consumers that generate the positive externality on the A consumers, right? So let's lower the price for the B side, right, from 5 down to 4.5. And let's raise the price on the A side and extract our profit essentially from advertisers. Notice like the value of this example, it's this line right here. It's talking about using this as a benchmark and then thinking about this logic. We want to raise price on the customers that don't generate the positive externality and lower the price on those that do. Right? We're extracting the profits from the more inelastic side of the market. In this case, extracting profits from, in some sense, from advertisers and incentivizing readers to join the market to create this large value for advertisers. Here's the more general thing, and as I'm going through the more general analysis, the important part really here is the interpretation of each of these coefficients. So I'm not going to have you solve out like the general version of the problem. That's just sort of a it's even more advanced than intermediate micro in some sense. It's kind of a mess, so we don't want to deal with that. But we do want to think about the interpretations of these things because it's important for reinforcing the concept. All right, so if these are our general demands, this is the coefficient. This is the slope on the price of good A. This is the externality exerted from side B on side A's demand. This is the externality exerted from side A on side B's demand. This is the slope from side B. So we could show as gamma A, as the positive externality that group B consumers are giving to the group A consumers increases, well, we would want to lower PB. Why? Well, the lower PB means lower PB means a higher QB, right? If we lower PB, higher QB, that's just law of demand. Higher QB, oh, that's going to have this increasing effect on QA, right? Maybe we'd even want to make PB negative, especially if gamma A is large enough. Try to make this so we give away free things to the B side of the market to increase our demand on the A side. Lots of times we'd want to increase PA and extract our profits from the side A. What happens when we're raising PA? Well, that's going to lower QA, but hopefully that's attenuated by this increase in QB, right? If we lower this price, that's going to raise QB, which is going to create this additional value, which is going to allow us to raise PA, right? The intuition is you want to relatively subsidize the group that most benefits the other group, creating an additional incentive for those high-value customers to join. All right. And then here's again looking at what's happening with beta A. So now let's take a look at this. As beta A, this is how sensitive PA is to price decreases. As group A becomes less sensitive to price, you definitely want to raise the price on them, right? As demand's becoming more inelastic, yeah, raise the price. And you probably want to decrease PB. Again, because so as we decrease PB, that's increasing QB, that's creating this positive network externality that is benefiting demanders on side A. So let's raise PA. As they're becoming increasingly insensitive to that price, let's keep raising the price. So again, we want to optimally extract profits from the side of the market that's more easy to extract those profits from, the side that's least price sensitive. So the basic idea with our platform markets is we are trying to generate this large base of users, which is going to create this positive externality on the other side of the market. So we have a large number of users on Facebook. This creates this pool that advertisers want to reach. So adding more users to Facebook increases the value for advertisers, which increases the price we can charge advertisers to advertise on that market. And the idea is each additional consumer that joins the market, each additional user that joins the market is creating value that Facebook can extract through the advertisers. That's the idea. So each additional person that joins increases the economic surplus the network's creating, which then the firm is able to extract. What do we learn? Well, as usual in the course, we can think about these things either more loosely and intuitively to shape our strategy or more formally and quantitatively. I actually like the more loosely and intuitively at this stage because this is giving us this sort of nice conceptual framework then to bring to bear on a large number of problems. So our analysis suggests we should think about, well, which side is creating the most benefit for the other side of the market? As I did with the sort of the Facebook and users and advertisers example, you can think of like open table, or you can think of like media or social media markets. Which side is more or less sensitive to price? Charge the higher prices from the less sensitive side of the market, lower prices from the more sensitive side. Well, suppose we actually want to do this more rigorously. How do we do that? More formally and quantitatively, we want to estimate the demand side on both sides of the market. We'd use the market experimentation or the customer surveys that we introduced really early in the course. And then you'd put these estimated demand curves into our profit maximization problem, inclusive of this network effect, and then determine the optimal prices. Again, the model I just showed is probably the simplest model for a platform market that we'd be able to have. Two sides of the market, single externality. We didn't care in this platform example about the network externality exerted between users so far. We can think about other more interesting, more complex aspects of these markets. And so in our market, or in our model, consumers decided only whether to enter the market, not how much to use the platform. So we just had one single price to set. In this case, we'd think about just the price for the consumer to enter that side of the market. We could also think of a situation where there's this intensity question, which we can now capture by embedding our two-part tariff pricing into our platform market. So in general, we might have a situation where consumers are choosing both to access the market and then how much to use the market, which allows firms to use two-part tariffs by charging an access fee and a usage fee. So for instance, eBay could use a listing fee, their access fee, and a final value fee that's like a usage fee. Or OpenTable charges an access fee plus a commission on all reservations. So access fee for restaurants plus a commission on all the reservations, right? This is like the fixed portion of the two-part tariff. This is like the per unit portion, right? It's kind of cool. Now, if you're going to do this, if you use a two-part tariff embedded in our platform or network market strategy, you have to think about whether to extract revenues from the access fees, from the usage fees, or for both. And there's some important implications. In particular, the access fees, yes, is a very effective way to extract surplus, right? We saw this with the standard two-part tariff example. On the other hand, the access fees, or if we had a subsidy, in the case of like a negative access fee, subsidizing usage, can be more easily targeted towards one side of the market. So the access fee, the subsidy, you charge an access fee, in this case, to restaurants on OpenTable, or you give a subsidy to users. Why can this be more easily targeted towards one side of the market. Why can this be harder with usage fees? Well, usage fees like a per unit fee. And to get this line, to get this intuition correct, why the access fee can be more easily targeted than the usage fee, think about the way in which these things distort incentives, and think about like taxes, for instance. If you have a lump sum tax, that's like the access fee or subsidy, that's a fixed thing that's going to be irrelevant for marginal decisions. You can just target this to one side of the market. It's not going to affect the marginal decision. Same thing with two-part tariff. The access fee didn't have any impact on the subsequent quantity demanded for either side of the market or for either type of consumer. With usage fees, however, there is this distortionary effect. Think about tax incidence, right? Both sides of the market, if you tax buyers or tax sellers, this is like Econ 101 principles of micro. If you put a tax on buyers or you put a tax on sellers, both sides of the market are going to pay the tax. Which side of the market pays the larger share of the tax depends on which side is more inelastic. Tax incidence depends on which side is more inelastic, such that the usage fee on restaurant users is going to be borne also by restaurants themselves and vice versa. And so the more inelastic side of the market is going to bear the larger burden, but unless one side is perfectly inelastic, both sides are going to split the burden of a usage fee, just like both sides of the market would bear a tax incidence or the incidence of a tax. All right, for a new product that customers are unsure about, they might not want to pay the upfront access fee. So usage fees might be more effective, right? If you don't want to pay for access to something you're not sure of, maybe give away free access or whatever, but we'd want to extract our profits from usage fees. People are going to be a little bit more interested in paying for a usage fee because then they know, well, they're using it. You can think about this relative to eBay, right? Another factor favoring usage fees is they sometimes are better at limiting the risk customers face. Risk-averse customers might be more willing to pay for this. Think about eBay listing versus final value fees. Do you want to pay to list an item that may or may not sell? Then you're going to pay for sure to list the thing, and you might not sell the item. Versus the final value fee, if you have to pay some percentage of the final sale, maybe you're more willing to sign up for that because you know you've made the sale at that point, and so then you've extracted some value. This is just a duplicate slide. So thinking about our simple model, well, the customers inside A of the market only cared about the number of consumers on the B side. Same vice versa. But in general, they might care about the types, incomes, ages, other demographics of customers on the B side of the market, because A side is like our advertisers, the B side is like the users that the advertisers are trying to market to. For example, advertisers don't just care about how many people see their ad, they care about what type sees their ad. So like Free PC in 1999 was this company where you'd have this free computer, get bombarded by all these advertisements. I don't know. In some sense, it's brilliant on paper to some extent, but the irritation factor is huge, and so we'd expect at a certain point people are just not going to. And of course, it's not around today. So, but you care very much about the type of people seeing your ad because then you're able to reach those individuals. All right. This can affect the profit maximizing access and usage fees, possibly in different ways, such as eBay. And ideally, we want to take this in consideration. But the demand model gets much more complicated once we start thinking about the different types of consumers. All right. So here, thinking about what this would look like more formally. Previously, our type A consumers only cared about how many B consumers there are. But our A consumers might also care about how many A types there are. So for instance, Facebook users might care about how Facebook advertisers might care about other advertisers. So here's our demands. My demand from, for instance, advertisers. Remember B was like so all along I've been talking about our advertisers being our A side and our users being our B side. Now we've switched this. All right, so fine. Our suppose A is our users, B is our advertisers. Now what's going to happen? So my demands for my users and then my demands for my advertisers. Good. We've hypothesized gamma A is small, maybe 0 or negative, right? Gamma A is going to be the externality exerted by advertisers on demand for users, right? Users probably don't want a lot of advertisements. YB is probably large. Why am I saying Y? It's a gamma. So gamma B is probably large. So the number of users is increasing this positive externality that influences demand for advertisers. Delta A is probably large. So this is the positive externality exerted by the number of users on the demand for other users. And then gamma B is probably small, possibly negative, where this is like the negative externality exerted by advertisers on other advertisers because your ad gets swamped out or consumers start ignoring them or just get annoyed. Right. Anyway, so the dynamics of platform markets quite a bit like the dynamics of the market with network effects. Ultimately, if we have switching costs or if we have durable products, once one product or one platform has a big market share, it's really difficult for a competitor to challenge it because you've got these large network externalities actually now on both sides of the market. It's not completely impossible, right? MySpace had a pretty large customer base, user base. I had like 4 accounts and versus Facebook, which was able to overcome MySpace. This again leads to optimal strategies involving starting with lower zero prices. Why? To try to grow the side of the market that's going to benefit the side that you're going to later be able to extract profits from. Maybe even on both sides of the market, you initially might have lower zero prices. Why? To build up this large installed base and then raise the prices later on. If you're trying to launch an app, you're trying to have some type of platform market, you have to have a large number of users. You have to have people adopt the network. Otherwise, it's just not going to survive. It's just not going to be around. And so the reason why is because most of the value, if you're creating an app that involves some type of network or platform effect, most of the value is not created by you. Most of the value is created by other users. What you are doing is you are creating the environment, the foundation on which the other value is created. So you're creating an environment, a biome that these other users are going to come in and then cultivate. And that's kind of the way to think about a platform or a network market. All right, so here's an example thinking about eBay. So thinking about their pricing dynamics later on, but thinking about this platform market more centrally. So initially launched in '95 as an auction web. It was the first auction site for customer-to-customer transactions. Since the late 1990s, it's been incredibly dominant, which fits in with our platform market analysis, right? We got sellers on one side, buyers on the other side. Sellers care about how many buyers there are, buyers care about how many sellers there are, and then how does this influence our strategy? Well, the value added. Let's look at the value added for online auctions. It's huge, right? The value added is the area between the demand curve and the cost curve. It's high. Why? Well, a lot of reasons. It ultimately comes down to lower transaction costs, right? So this is essentially a superior substitute to the standard brick and mortar. Like a standard auction, I used to live right next to an auction house when I was growing up in Wisconsin. Classified as collectible shows, there's much higher transaction costs for all these. You have to go to a physical location. Everybody's got to be there. The products you might want might not even be there. You might not know. You might not be able to determine what auctions are coming up. They'll advertise in advance, but it's just kind of a mess, right? So why is eBay superior? Well, there's a lot more people. The geography doesn't matter. The item that you're interested in might be on the other side of the country or the other side of the world. Who cares? You can still buy it, still bid on it at least. There's much lower transaction costs. Think about that. That's kind of like the key to entrepreneurship at the present time is like lowering transaction costs, is creating a lot of new markets, and it's sort of a lot of like modern entrepreneurs. In general, like that's kind of the point of entrepreneurship is to lower transaction costs and to reorganize, to take resources from lower valued uses to higher valued uses and kind of eliminating inefficiency. The market's ultimately, much more efficient through the information gains that's available from the online format, especially through reputation and product reviews. All right, so thinking about the 5 forces analysis, this is relevant for like review and then for thinking about how the pre-business project will go. Definitely, there's marketing power of buyers and sellers. The big early issue was the internet portals. Things like Yahoo and AOL had control over internet users. AOL was terrible. It gave this kind of snapshot of the internet, right? At the introduction, there's no significant competitors or substitutes, clearly inferior goods from the brick and mortar companies. The most important force here to consider was potential entrants. And so this is the one where you'd have like low to medium for everything for our Porter's 5 forces, but you'd have like kind of a high threat from entry. So then eBay had to be kind of wise? Well, the strong market externalities, strong platform market externalities helps deter entry if it builds up an installed base, and it was able to do that. On the other hand, there's not a durable good. There doesn't seem to be really large switching costs. I mean, is it really hard for buyers or sellers to leave for another site? Not initially, but you can create a situation where it is, right? So it's not conceivable, even if you started with a large market share, price increases could cause everybody to switch sites unless you do something that makes that sort of unattractive. So that's what they do. First off, they keep prices low enough to prevent entry. Second, you make these endogenous sunk costs, sunk overinvestments into quality to deter entry. Make it even harder for entry because a potential entrant would have to match that. Ultimately, they were able to create massive switching costs, which made it easier to raise prices later on. So what did they do? Well, their investments in this feedback system was crucial, especially in creating, because once a seller creates a reputation on one site, you can't necessarily take that reputation to another site. And so that's a massive switching cost. And that's one of the things that actually, prevented this sort of defection to other sites. All right, so pricing initially started free, then there's a long path of price increases. Pretty clearly what's going on is you got this building up of an installed base, then there's some type of limit pricing to deter entry and then prevent customer defections. There's large overinvestments in quality in order to deter entry and to enhance the network effects, so such things as security, insurance, feedback ratings, and forums. This is completely not portable. Verified user program. So these things are duplicable by other sites, security and insurance. Feedback and ratings and forums and the verified user program, that's difficult to duplicate because you've got this long history that's been established, long reputation that's been established. And once you've got that, that creates this massive switching cost, both for users and then but especially for sellers. Other things, well, buyout of PayPal probably was helpful in generating switching costs. The contract with key suppliers, so for instance, AOL at its peak. As a result, there's lots of failed entry. There's been no successful entrance into auctions. I mean, maybe the last like kind of serious one would be like CBS Sports auctions, with partnerships with NCAA and some other things, but that's about the only kind of really strong auction site kind of in the last 10 years or so. eBay's dominant positions never really been seriously threatened. So here was their pricing from 2001 to 2002. Well, there's a listing fee for the product. No, sorry, this is in terms of like our definition. So listing fee is the fee for listing the product, non-refundable. The final value fee is the fee for a successful sale. Okay, initially for $100 minimum bid item, eBay's listing fee was $2.20. 2.5% of the final value was the final value fee for a total of $5.37. Amazon, they had a 10-cent listing fee, 2.5% final value for a total of $3.27. And then Yahoo, no final value fee. Their total was just their listing fee. And then 2006 to 2007, $100 for the same $100 minimum bid item. eBay had a $2.40 listing fee, 2.75% listing fee. Their total was $5.77. 2007, rising up still. Amazon, still $3.27. What about Yahoo? Free until it shut down in June of 2007. And then pricing 2010, well, eBay had a $1 listing fee, 9% final value fee. So increasing fees to a total of $10 for a $100 fee. And then similar for $100 item, now there's no listing fee, and they're extracting entirely from the final value fee as of 2015. History of entry and other threats, well, there's On Sale, there's Auction Universe, Excite, Yahoo, Amazon, Auction Bots. Yahoo went to a zero price again in 2005, and then there's not been much since then. So anyway, hope you enjoyed the video, and don't forget about the Network Effects Part 2 video.